Welcome to Statistic 1, Chapter 6, the binomial distribution. Our topic today is the binomial distribution in detail. So, first of all, I would like to talk about the condition for a binomial distribution. We have three main things. So, condition here means that when a question can follow these three conditions, so we consider as a binomial distribution question. Our first rule is that there are just two possible outcomes, often referred to subset and failure. Let me take an example. When you throw a dice, you'll get 6 outcomes like 1, 2, 3, 4, 5, and 6. But a question asks you like this. Find what is the probability that you will get exactly to number 6. Mean that when you throw 10 times, so it means that when you throw a die 10 times, so what is the probability that you will get exactly 2 times is a 6 number. So here, it refers to subset or failure. In this question, subset means you get a 6. Failure means you do not get a 6. So failure means you get 1, 2, 3, 4, 5. So you don't have to. So you plus that. You take the sum to be the probability of failure, and the probability of your 6 will be the probability of subset. So even it turns out with a loss of outcome, final we take a look at the question to say that exactly to number 6 mean that they only care about the number 6 in here. So when you get a 6, you're subset. When you don't get a 6, you are failed. So it means that only 2 possible outcomes, getting a 6 or not getting a 6. On the other, they are called the same one. They are failure. They are the probability. The sum would be the probability of not getting a 6. Like I have, this is a fair dice. Fair dice is a fair dice. So the probabilities of x1 is the same and equal to 1 over 6. So probability of subset means that p of getting a 6 equal to 1 over 6, and p not getting a 6, no 6, equal to 5 over 6. These are 2 possible outcomes only, getting a 6 or not getting a 6. So the second one is that both outcomes have fixed probability and adding up to 1. The probability of a subset, usually called p, and the failure q, and p plus q is equal to 1. Now you can see that from this question, here's our probability of subset and here's our probabilities of failure. So these two must add up to 1 because the sum of probability always 1. Or let me take another example. The probability that you a piece of making mistake equal to 0.2. So p of not making mistake, because there are only 2 possible outcomes, so not making mistake. So when you facing up with a problem with mistake, here you can just making mistake or not making mistake, no other outcome. So because they add up to 1, so if they ask us to find this one, it's equal to 1 minus 0.2 equal to 0.8. And both outcomes have fixed probabilities. It means that on the first day you say that probability of getting a 6 is 1 over 6, and on the second day you say that the probability of that die change is now equal to 0.5. So it would not be the case. You don't consider that sample is failed when they provide you with a both outcome at fixed probability to day by day constant will never change according to times or affected by any other factor. It is a condition for the binomial distribution. And the probability of success in any trial is independent of the outcome of previous trial. So first, because here I say exactly 2 6, so first of all, when I get a 6 here, it not will affect that after that will I get a 6 or not. It will not affect because they are independent. They do not relate to each other, then they will not affect each other. Here, the probability that you will win contest A is equal to 0.2 and win contest B 0.5. They are not related to each other. Whether you win, if you win A, you cannot promise that you will win B or you will lose B. But if you do not win A, and that would not promise that you win B or lose B too. So when two events are independent, the success in any trial will not be affected by the previous trials and the next trial that you are going to make. Trial here means you do in an experiment. You do a lot of trial. You do it first. You do the first time. In here, like an experiment of throwing a die 10 times. The first time is that you throw a dice, and whatever you get, you will note it down. The second one, you throw a die a second time, and you get a probabilities. Here, I will show you how to use the binomial distribution through an exercise. I have an exercise here. In a well-known game, you have to decide which is your opponent is going to choose, paper, stone, or scissors. If you get entirely random, what is the probability that you will get right exactly 5 times out of 15? It means that you play this game 15 times and you win 5 times. So for our number of n, you see the word n here. N represent the number of trial that you do. In this case, you play the game 15 times, so number of trial 15 trial in your experiment. 15 trial, you do it 15 times. The probability that you will get it right is exactly 5 times. Because you get it right means that the number of times you succeed. The number of times you succeed is denoted as R. Number of times you succeed is denoted as R. So R equal to 5. Because here they say that probably that you get it right. So when you play a game, there are 3 options you have to face up with: that you win, you lose, or you have a draw when 2 people give the same paper or stone or scissors. But here they say that what is the probability that you are right, so mean that you are win, and D2 mean that you are not right, so you lose or you draw. So here you can see that there are only 2 possible outcomes. From that, we can use the binomial distribution. So n r means that number of times you succeed, and n minus r equal to the number of times you fail to get it right. Because we only have 2 possible outcomes. If the total number of times you do is 15 and the number of times you succeed is 5, so the number of times you fail to succeed means that you lose or a draw is equal to n minus r equal to 15 minus 5 equal to 10. 10 times you will fail. As I said before, in the previous slide, we can see that P is the probability that we are going to succeed, and Q is the probability that you are going to fail. Q is fail, P success, and P plus Q equal to 1, so these two equations are the same. And bracket N and R is just another way to show the N to R. Now we have our R equal to 5, so P, they say it exactly 5 times X equal to 5. Because our R is 5, we just apply the formula in here. We have number of trial is 15 trial. We choose R 5 times to success. We do it 15 times, we choose 5 times to success. We multiply by, because you have 3 options: paper, stone, and scissors. So the probability that you are going to succeed is 1 over 3. 1 over 3. You get one of these and you win. And the probability that you are going not to succeed, mean that the probability that you are going to fail is 1 minus 1 over 3, because you only have only 2 possible outcomes. Is get it right or not get it right. If get it right is 1 over 3, so probability that you will not get it right is 2 over 3. Because we want to win exactly 5 times, so the number here, you see that to the power of R, in this case is 5, multiplied by 2 over 3 to the power of 10. We can use our calculator to calculate our probability. Here is 0.214 is our probability of getting exactly 5 times our 15. So now let me take another question. The probability that we are going to win 10 times P of X equal to 10. So it will be equal to, in this case, the number of success time is 10 and the numbers of fail time is 5. We can get 15 to 10 multiplied by, we use the formula in here, multiplied by 1 over 3 to the power 10 multiplied by 2 over 3 to the power of 5 equal to 0.00670, because we have to make it 3 significant figure. We have to round it up to 3 significant figure here, which is really small. The probability that we will get it right 10 times if we do it random is really small. From the previous video, the videos about understanding binomial distribution, I've told you that binomial distribution is a random variable and is a kind of discrete random variable. So for the numbers of successes, X is a variable take a restricted set from X value from X ranging from 0 to n, in which has a known probability of occurring. It is discrete because it can only take on specific number. In here, for binomial distribution, it is a positive integer. It cannot take on something like the number of success time is 1.5. It doesn't make sense anymore. Or 3.6. It doesn't make sense at all. So it is a discrete random variable for binomial distribution. The random variable is usually denoted by the uppercase letters such as X or Y or Z. The particular value that they may take are written in lowercase such as R. To state that X had the binomial distribution B and P, you can use abbreviation x, b, and comma p. So now I will explain this one. Here, the word b means the binomial distribution. You have to remember that here means binomial. It will be distinctive with the n for the normal distribution in the next chapter. So remember that b means binomial, and here mean the numbers of trial in an experiment You see, p, as I told you before, p is the probability of success. Probability of success. And here, this notation, it means that x has a distribution. See something like this, you can understand it easily. X has the binomial distribution of n sample, and the probability of success is p. Now I will apply this rule for the previous question that we mentioned before. Like, we know that x is the random variable. It has a distribution of a binomial distribution. The number of times we play the game, scissors, stone, and paper, is 15 times, and the probability that we get it right is 1/3. So this means that from here we can read this one. We know that we do the experiment 15 times. This is a binomial distribution, and the probability of success is 1/3. So let's take a look at this question. There is a fault in a machine making microchip. With the result, only 80% of those it produced work. A random sample of 8 microchips made by this machine is taken. So now we would represent this one in this case, in this form. From here we know that it had a random variable. It had a binomial distribution. We take a random sample of 8 microchips, so number of n is 8, and we know that only 80% of those it produced were, mean that the probability of success is 0.8. Here equal to 0.8. That's how we present a binomial distribution in this case. From a question that we have, we can write the question in this form in order to understand it easily and really simple. And from this form, we can understand what the question is talking about.